So today we are chatting about curvy coordinate geometry. We went through the theory last week, and today we're doing questions, and we already have questions. Okay, so let us get going with curvy coordinate geometry. Past paper questions for these, it is often not as visual as the ones for lines, okay? So we're often not working with graph. We're often also tying this in with other topics, bringing it in with functions, and then bringing it in also some of the concepts when we move into trig. So when we talked about the techniques last week, we talked about shapes and general shapes of graph and sketching graphs, and we talked about what happens with the graphs. And the thing about is that we're not going to talk so much about that today, because questions for that come with functions and with calculus and with trig. So we will be referring back to that as we move forward. So today we're going to focus on what is sort of classified as your coordinate geometry questions. And so it is more with your very good friend, the discriminant. And if you have taken the time while I've been slabbing to actually read the question that's showing here, I'm hoping that those bells were ringing. Question says, find the set of values of k for which the curve y equals kx squared minus 3x and the line y equals x minus k do not meet. 3 marks. Okay, and it's from winter 2016, paper 13, and it is question 1. So question 1 in your paper is generally a small mark. But the thing is to remember is to not get tricked by the small mark questions. Just because they're small marks doesn't mean you don't need to think. You still need to take just as much care with these questions. So things to note, set of values of k. So that's indicating we're going to have inequalities involved. Okay? A value of k would mean we're going to have an equals involved. We have a curve and we have a line. More importantly than that, we have here a quadratic. Okay? And so as soon as we trigger in quadratic thoughts and we see do not meet, we're seeing b squared minus 4ac is less than 0, our discriminant. Okay, so as we work through this question, it's a case of what are we going to do, okay? In order to use our discriminant, we need to get these 2 separate equations into 1. So we need to do the intersection. So for equation of intersection, we would then have, okay, so I like to write them down, so you're going to have to just deal with it. Okay, what I get by writing out of these is that I can see is y equals, straightforward, I'm quite happy, I can equate my y's. Simplified version of simultaneous by substitution. So kx squared minus 3x equals x minus k. Everybody on one side, kx squared minus 3x minus k minus 4x. And then bringing across the k, so plus k on both sides, it removes him. Now we have our quadratic. We have an a term, ax squared plus bx plus c. So we can now use our discriminant. So we can't solve this for k. It's not a case where we can solve for k, solve for x, because it's 2 unknowns, we only have 1 equation. Okay, so we have to use the information in the question rather to help us solve for k. And that wonderful thing about the discriminant is as soon as you apply the discriminant, all the x's disappear. And if the x's disappear, you're left just with k's. 1 equation, well in this case inequality, 1 variable you can solve. So, for values of k, we know that b squared minus 4ac is less than 0. Okay, we don't go through the process of writing formulas in our answer because a formula is a formula. It's something we're going to use, not that we're going to write down. Okay, so b squared minus 4ac, b squared, so minus 4 squared minus 4, a is k and c is k, and it is less than 0. So just for those of you who are not quite so happy with the quadratics at this stage, Coefficient of x squared is your a. Coefficient of your x term is your b. And your whole constant term is your c. Okie dokie, right, carrying on. So minus 4 times minus 4 is 16. Remember that minus 4 is inside the brackets. So be careful of your signs. Minus 4k squared is less than 0. Right, and now we should have another set of bells ringing. Lovely question, don't you think, ladies and gentlemen? We have ended up with a quadratic inequality. So we can now say that 16 is less than 4k squared. We can say k squared is greater than 16 divided by 4 is 4. And that's it. Okay, now we got to think. Remember, when we take the square root, we get plus minus 2. Okay, but we're not dealing with that. So we can't say greater than minus 2, greater than 2. That makes absolutely no sense if you try to draw it on a number line. So let's have a think about this one. For critical values, okay, we would say 4 equals k squared in this case, k equals plus minus 2. So if we now have a think of a mini sketch, we would have minus 2 and 2. Now we've got things a little bit slightly differently because we have worked with a k squared is greater than 4. We're working with square numbers here, okay? But think about it in the same way. Okay, so this is the same way as if we did, let's do it longhand for those of you who are visual like me. If we had done k squared minus 4 equals 0, then we would have had k plus 2, k minus 2, because we've got difference between two squares, k equals plus or minus 2. And this, of course, came from k squared minus 4 is greater than 0. So you can see in actual fact, even though in this case we have a special situation with our square number, it works the same as when we do our critical values quadratic related to 0. Okay, so quadratic is greater than 0. Quadratic is greater than 4. We move the 4 across, quadratic greater than 0. So we would be looking at these two. So our answer is, whoopsie daisy, k is less than minus 2 and k is greater than 2. That is our set of values of k for which the line and the curve are not going to meet. So nice revision of quadratic inequalities, nice revision of discriminant. And that's what we're pulling through when we do these curvy coordinate geometry questions. Any particular questions with this one, or shall we carry on to the next one? Type fast, or wait. It's a bit irritating because it doesn't even tell me if you are in the process of typing. Okay, so nobody has typed very fast, so we'll carry on to the next question. Right, question 2. The equation of a line is 2y plus x equals k, where k is a constant. And the equation of a curve is xy equals 6. In the case where k equals 8, the line intersects the curve at points A and B. Find the equation of the perpendicular bisector of the line AB. Goodness, it's a lot of words. Okay, so in the case where k equals 8, so we have 2y plus x equals 8. And we have xy equals 6. Okay, in this case, line intersects curves. So, random sketch to understand, line and curve. Intersects at AB. Find the equation of the perpendicular bisector of the line AB. Okay, that's through the midpoint of AB and it's at 90 degrees. So again, lovely revision of our straight line coordinate geometry work this time. So let us work through it. Okay. In order to be able to get point M, which we need for our line, we have to get A and B. In order to get the gradient of our line that we want to calculate, we need the gradient of AB. In order to get everything, in other words, we need AB, and in order to get AB, we need the intersection. Intersection between a line and a curve is exactly the same as the intersection between two lines. It's their simultaneous solution. So, making our lives easy. X is the same as 8 minus 2y. So, for coordinates, see if you can spell coordinates of A and B. That's where we go to start. We can say that 8 minus 2y times y equals 6. So 8y minus 2y squared equals 6. Whoa, equals 6. We're going to get a bit fancy. We're going to bring it across and divide by 2 all at once. So 2y squared becomes y squared, plus 8y becomes minus 4y, and our plus 6 becomes plus 3. So we can solve for y. We factorize, always our preferred method of solution, because it is quick, it is easy, and it is less prone to errors than using other longer methods. Factors of 3 which add to give us 4 is 3 and 1. And like signs, and they are both negative. So y equals 3 and y equals 1. So our x coordinates, x equals 8 minus 2 times 3, and x equals 8 minus 2 times 1. So 8 minus 6, x equals 2. 8 minus 2, x equals 6. So they didn't tell us which one is which, so it is up to us which way round we go. So we have, let's call A is the point 2, 3, and B is the point 6, 1. All we've got now is our coordinates. Okay, so what we're going to do is go back to our question and remind ourselves what did we need. So 2, 3, and 6, 1. So we're building our sketch with the information, because then everything is all in one place. It makes it easier to reference and to move forward from. Right. So find the equation of this perpendicular bisector. Equation of a line, y minus y1 equals m, x minus x1. Two pieces of information needed, a point and a gradient. So both of them come from AB. Let's do the point first. So for point on line, again, we're structuring our answer using subheadings to make it easier to check back later, to make it easier to follow what we did, keep track of our working, and then also then to make life easier for our examiner. So midpoint of AB equals 2 plus 6 over 2, 3 plus 1 over 2, okay, and we are inside brackets with a comma, we're building a coordinate from the very beginning. So midpoint of AB is 8 divided by 2 is 4, 4 divided by 2 is 2. For gradient of AB, okay, gradient AB, little m for gradient, big M for midpoint. We want y change, so 3 minus 1 over x change. 2 minus 6, and there's our coordinate pairs lining up beautifully. So 3 minus 1 gives us 2. 2 minus 6 gives us minus 4, so we're left with minus a half. And then we realize we didn't give ourselves enough space when I put this together, so we are going to go to my backup page, which is all the way down here. There we go. So we're on question 2, part 1. Okay, and we are now ready for equation of the line, this perpendicular bisector that they want. So our point was, and our gradient equals. So rewind, point is 4, 2. Gradient is going to be 2, because remember perpendicular, we're going to flip and change the sign. So 4, 2, and 2, and we remember it. 4, 2, and 2. Remember, we don't just randomly write it down. M1, M2 equals minus 1 for perpendicular lines. Now we can go for it. Y minus 2 equals mx minus 4. Y minus 2 equals 2x minus 8. Y equals 2x minus 6. And there's our equation of our perpendicular bisector of AB. That was the end of that question. Okay, so hopefully there's no quick typing. There's no questions with that. Nice revision of straight line work. Okay, but a reminder that intersections for curves and lines is the same as intersections for lines. It all works in the same way. Right. Now we get curvy again. Find the set of values of k for which the line 2y plus x equals k intersects the curve xy. So 2y plus x equals k intersects the curve xy equals 6 at two distinct points. B squared minus 4ac greater than 0, but this is for a quadratic. Okay, so you have to think a little bit nicely here and say, okay, but neither of these is a quadratic. But when I put them together, we're going to have magic. Because if you think this again, let's go with the easy one, x equals k minus 2y. So when I substitute this in for here, I'm going to end up with a y times a y term, which is going to give me a quadratic in y squared. Does it matter if it's in x or y? No, it doesn't. Okay, because both the x equals and the y equals, they're both representing the same relationship. It's a relationship between this line and this curve. So it doesn't matter which way around we go. The discriminant works on quadratics in anything, not just quadratics in x. Okay, so now we're happy. We are reassured. We're going to head towards that quadratic, then we're going to be able to use that discriminant. So, for intersection equation, we're going to say x is 2k minus 2y times y equals 6. So ky minus 2y squared equals 6, and then we move everybody because we like a happy quadratic. Just makes life a little bit easier. Okay, and then set of values of k, again, this is going to be inequalities involved. So it links in quite nicely with the fact that b squared minus 4ac is greater than 0. So next step, for values of k, we would have b squared minus 4ac minus k squared minus 4ac. And in this case, we have said two distinct points. So they are real and they are different. It is greater than 0. So, magic, hey? K squared minus 2 times 4 is 8. 8 sixes is 48. Greater than 0. Have I done something wrong, or did I pick a question with random answers? It appears I have picked a question with random answers. Okay, so quadratic inequality. We can still do this, ladies and gentlemen. It is not a problem in our lives. So quadratic inequality, okay, it means that we need, for critical values, and we're going to say k squared minus 48 equals 0. So k squared equals 0, k equals plus or minus, this one I shall do on my calculator, 4√3. And we're perfectly capable of working in surd format, nice and precise. So, same thing, we have minus 4√3, we have plus 4√3, we have our mini sketch. Okay, we are looking for greater than 0, so we are looking for those two zones. So, k is less than minus 4√3, or k is greater than 4√3. Okay, at least I know that Emma is awake. Thank you, Emma. K squared is not equal to 0, except in the place where my imagination runs away with me. K squared equals 48. Okay, so be careful of sprinting through maths questions because you make mistakes. Hopefully the rest of it was right. Please do shout if I do make wobbles. Okay, right, so everybody else happy with everything else? Fingers crossed, K is less than minus 4 root 3 and K is greater than 4 root 3. 2 zones for our quadratic inequality. Right, so we got the set of values of K, we got our intersection, we got 2 distinct points. So what's happening next? 6 minutes for another question. We'll see how far we get. Okay, so here we have a curve 7 root x and a line y equals 6x plus k, where k is a constant. We have intersections at a and b, and they've drawn it for us this time. So find the case, for the case where k equals 2, find the x coordinates of a and b. You're seeing there's a pattern here, and this is what happens when you start doing questions of the same type over and over again. See, it's the same question over and over again. They're just asking it in different ways. So while you're learning it, it is fantastic to do topic questions. When you get more into revision, it's important to start mixing up your topics because your brain has to be able to leap into different topics and answer those questions. So we have y equals 6x plus 2, and we have y equals 7 root x. We want to find the x coordinates only of a and b. So we want to solve x equals. Okay, y equals, simplified substitution. We can just say 6x plus 2 equals 7 root x. So 6x minus 7 root x plus 2 equals 0. Can you see it? This is one of those beautiful equations that reduces to a quadratic because root x times root x is x. So we have here something root x, and we have a 2. So let's see if we can do this. A 2 and a 1. We have the width because that's the only way you can factorize 2, it's prime. Okay, then we have something root x, and we have something root x. Okay, we need like signs. We need to make minus 7, and we have 6. So we want like signs, making a minus 7. So something times 2 and something times 1. So 2, 3, there we go. Let's just check. 2 times 3 gives us the 6. 2 times 2 gives us 4, 3 times 1 gives us 3, and 4 and 3 gives us 7. Okay, so slightly slower because we're working with funner numbers, but now we've got our 2 answers. So we have 3 root x minus 2 equals 0, or we have 2 root x minus 1 equals 0. So root x equals 2 over 3, x equals 4 over 9, and here we have root x equals a half, x equals a quarter. There's our 2 x coordinates for A and B. Okay, so a little bit more fun with algebra. And let's just keep moving. Everybody happy? Nobody crying? No problems, no typos? Nobody's typing fast. Okay, so next part of this question is find the value of k for which the line is a tangent to the curve. We have bells ringing again because when we have a tangent to the curve, we are dealing with b squared minus 4ac equals 0. And we have already seen that we are working with something that reduces to a quadratic. So y equals 6x plus k, y equals 7 root x. Okay, so for equation of intersection, 6x plus k equals 7 root x. So 6x minus 7 root x plus k equals 0. Okay, and our discriminant will work on this because this is in effect a quadratic. So a is 6, b is minus 7. So for value of k, b squared minus 4ac equals 0. So 49 minus 4 times 6 gives us 24 equals 0. 49 equals 24k. So 49 divided by 24 just stays like he is. K is 49 over 24. Okay. Sometimes you manage to pick questions that just give you weird and wonderful numbers. Okay, it happens. Is everybody happy? Okay, with this concept of when we have intersections, we are doing simultaneous equations. So when we have intersections and types of intersections, we have information about that intersections. Whenever we're anywhere near a quadratic, we're using our discriminant. If we're something near a cubic or some other funny function, then we're going to have to sketch and we're going to have to look. Okay, but that's going to come up more when we look at functions and other types of things in calculus and then in trig. So for now, we're sticking to our life of quadratics. All right, so hopefully everybody's happy.